Hey everyone, welcome back to Through Inquisitive Kids. Today we're going to be looking at two exponential equations with a quadratic exponent. And in both of these equations, you will see that we are solving for a variable that is both on the base and on the exponent part of these equations. So let's dive into the first one. The base is 2x plus 6, and it's raised to the power of x squared minus 9. This entire expression equals 1, so we have to solve for x. Now this is a very special case where we see that the value of the entire expression right here on the left side is equal to 1, which means that there can only be 3 cases. So let's say that our expression was a to the power of b, right? And it was equal to 1. There are 3 cases in which that this expression would be equal to 1. In one case would be if the base, a, is equal to 1 itself, right? 1 raised to the power of anything is always still 1. The second case would be if a did not equal 0, so meaning that the base itself does not equal 0, but b does equal 0. So the exponent is 0. Anything that is not 0 raised to the power of 0 is equal to 1. And you have to make sure that you know that 0 raised to the power of 0 is undefined. So this cannot happen. That's why we must emphasize that a cannot equal 0 itself. The base can't be 0. Finally, the third case is if a is equal to negative 1, yet b, the exponent, is even. So we have to find a case where the base is negative 1 and the exponent is even. So these are the 3 cases that will make an exponential expression equal to 1. So now let's apply these 3 cases to the first problem. Here, how can we substitute a? Well, let's look at the first scenario, right? A is equal to 1 itself, which means that the base, 2x plus 6, is equal to 1. Now, if we were to solve this, x is equal to negative 2.5. So this would be the first solution of x, right? If x is equal to negative 2.5, this expression is equal to 1. You should definitely substitute your solution back into the equation just to make sure. Now let's look at the second case. The second case is if the base is not equal to 0, but the exponent is equal to 0. Let's start with the exponent. In this case, x squared minus 9 is equal to 0. So x can be equal to positive 3, or x can be equal to negative 3. Now we have to discuss these 2 cases separately. Make sure that you're writing it really organized so you know, oh, these are the 2 cases and I have to evaluate them separately to see if they are valid. Let's substitute x is equal to 3 back into the base to see if it fits the second part. A is not equal to 0, or the base is not equal to 0. Well, 2x, so 2 times 3, plus 6 does not equal to 0. So this first solution is correct. X can equal 3. Let's check the second one. 2 times negative 3 plus 6 indeed does equal 0, which means that after substituting, remember the big part is to substitute to show and check that your work is right. Now that we've substituted, we found out that x cannot equal negative 3. So this is not a valid solution. Now let's look at the third possible case. A is equal to negative 1 and b is even. Well, if 2x plus 6, the base, is equal to negative 1, then x is equal to negative 3.5. And now let's substitute this back into the exponent to see if it will become even. Well, once we substitute this back into x squared minus 9, we will see that because there is a decimal, obviously it cannot be even. So it means that this solution is not valid. It is not a solution for this equation. Therefore, our two solutions would be x is equal to negative 2.5 and x is equal to 3. These are the two solutions to this problem. Remember, when you're solving equations like this, make sure that you find all of the possible solutions, not just one, and make sure that you're checking every single step by substituting so that you are making sure that all of your solutions are valid. Now we're going to be using these three conditions to solve the second problem. So let's check out the first possible case. The first possible case would be if the base is equal to 1. So 9 minus 2x is equal to 1. If we were to solve this equation, we'll have x is equal to 4. So this is a possible solution because if we substitute it back in, we'll see that it makes the base equal to 1. 1 raised to any power is always equal to itself. Now if we look at the second condition, can we make the base not equal to 0 while making the exponent part equal to 0? Well, let's start with the exponent part. X squared plus 2x minus 24 has to be equal to 0. And now all we're doing here is factoring the quadratic. Now for anyone who is unfamiliar with factoring, we have two zeros, the two opposite of the zeros. So these two zeros, let's call them little a and little b. Their product is always this number right here, the constant. So a times b is equal to negative 4. A plus b is equal to the coefficient of the second term, which is 2 in this case. So from this, we know that the two opposites of the zeros would be a is equal to negative 4, while b is equal to positive 6. And you can change the order. It doesn't really matter. In the end, now that we know that these are the opposite of zeros, we know the zeros of the equation. We can factor this quadratic equation into x minus 4 times x plus 6 is equal to 0. Therefore, the two solutions of x that would make the expression 0 would be x is equal to 4 or x is equal to negative 6. Let's test out both ways. We already know that x is equal to 4 is a solution. So that is definitely a solution. And if x is equal to negative 6, does that fit the second part of the criteria, that the base is not equal to 0? Well, by substituting x is equal to negative 6 back into the base, which is 9 minus 2x, 9 minus 2 times negative 6 indeed does not equal 0, which means that x is equal to negative 6 is also a valid solution. Finally, let's look at the third case, which is that if the base is equal to negative 1 and that the exponent is even. So 9 minus 2x, the base, has to be equal to negative 1. In this case, x is equal to 5. And now let's substitute 5 back into the exponent. Through substitution, we'll see that we have 25 plus 10 minus 24. This gives us an odd answer, which is equal to 11. So because this does not fit the second part of the third criteria, it means that x is equal to 5 is not a valid solution. Therefore, for the second problem, we have two distinct solutions. X is equal to 4 or x is equal to negative 6. Remember, the main point that we need to get from solving these two problems is knowing that whenever you have a variable show up two times on two different parts of an exponential equation, you must verify that your answer has all of the solutions and only the valid solutions. Substituting each of your solutions back into the original expression will always help you check if you have it right or not. Thank you so much for watching through Inquisitive Kids, and we'll see you next time. Have a good one.